Alright, in this video we're going to investigate angular motion and look at a couple of key concepts within angular motion, including torque and also how to calculate angular velocity. So once again, angular motion sits within biomechanical analysis in the area of motion. So we've got linear motion and angular motion. Angular motion can be defined as movement which occurs around an axis, so often occurs in sports like gymnastics and also diving. There's also angular motion in the body, so when you walk, your thighs and your femur rotate about the hip joint, so that's angular motion. The lower leg rotates around the knee joint and the foot rotates around the ankle. So those smaller elements of angular motion, when put together, allow us to move in a linear fashion. Now, torque is an important concept. Torque is a measure of the force that occurs when we're spinning around something. It's also referred to as moment of force, and we can calculate the torque by multiplying the force that's being applied through an object or a person and times that by the lever arm. So the lever arm is the distance from the axis, which in this case is the bar, to the center of gravity or center of mass of that object, which at this point is this little circle here on this person. So that would give us a measure of the amount of torque that is occurring in this person spinning around the bar. So torque can be affected by the length of the lever arm and also by the amount of force applied. And this is important in sport because particularly in sports where there is angular motion, say for example in cricket, if you have a longer bat and you're applying the same amount of force, you can potentially generate a greater shot because your torque is increased. There's also the other side of that is in sports like swimming, where if we increase the lever arm, so we stretch out our arms and we do big windmills circumducting our arms, that can actually increase the torque, which puts a lot of strain on the shoulder joint, which swimmers don't really want when they're swimming long distances. So this is how torque can apply to different sporting examples. An example down here is how we can apply torque to a volleyball or a soccer ball. When you hit the ball on the side, you can apply a torque to that ball and it spins, and that can cause movement through the air, which can make it hard to defend. So similar to linear motion, we've got angular distance and angular displacement, and they're no different to linear motion in that distance measures the actual distance covered. So if someone rotates around two big full circles around this bar, they would have covered 720 degrees in distance. Their displacement, however, would be zero because they've come back to the starting point. So displacement again is how far we've come from our starting point. The angular speed, similar again to linear motion, is calculated by dividing angular distance by the time that it takes to complete that rotation. The velocity, angular velocity, is calculated by dividing the angular displacement by the time taken. And the angular acceleration is a measure of how whether something is increasing its speed in terms of speeding up while it's rotating or slowing down, which we can also call deceleration. So in the first example here, we've been asked to demonstrate the angular displacement of the gymnast in position E compared to when they're in position B. And the answer to that question is that they have travelled 180 degrees from their starting point, which means that the angular displacement equals 180 degrees. Second worked example, if the time taken to rotate from position E to position B is 3 seconds, calculate the angular velocity of the gymnast. So we need two variables here. So we need to work out our angular displacement, which we did in the previous question. So that's 180 degrees. And the time taken, which we've been given, is 3 seconds. Therefore, we go angular velocity equals the angular displacement, which is 180 degrees, divided by the time, which is 3 seconds, which gives us our answer, which is 60 degrees per second. So that person is rotating at 60 degrees per second. So it's a measure of how fast they're spinning. Get you to go to your notebook and click on the angular motion page. There's a few videos which you can watch there. There's a really good video of Matt Mitchum doing his diving, so he won gold medal at the 2008 Olympics. And there's some structured questions. So the first one, you need to read page 74 and answer the following questions about swimming. And the second set of questions is refer to figure 417, which we've just been looking at, and complete questions A to D. If you finish that, you can have a go at some of the extension questions.